Assalamualaikum everyone. I hope you are all fine. Today's we will be discussing about the working of our routing information protocol, and we will see this through an example. So, what does routing information protocol do here? Is a distance vector protocol. Uh, we have discussed this distance vector protocol in a bit detail, and it is a Bellman-Ford algorithm based routing protocol. So what does RIP protocol do? It chooses the best route based on the minimum hop count. Let's see through an example what is an hop count. So in this example you can see there are some routers are been configured, around 7 routers are being configured. So there are 3 paths from if the source is destination is if the source is A and your destination is D, then there are 3 paths available. First path is from A to B and then C and then D, and second path is A, E and D, and third path is A, F, G and D. So the first path consisting of 3 hops. First hop is from A to B, second hop is B to C, and third hop is C to D. So you can reach the destination D if you are going through this route in 3 hops. So the second route has 2 hops, and the third route also has 3 hops. So RIP protocol basically chooses that route which has a lesser count of hops. So in this case the route number 2 will be chosen because route 2 has only 2 hops as compared to the other 2 routes available which are having 3 hops respectively. So how does routing will be done in the RIP protocol? First phase is an initialization phase. In this, every router will send a request packet on the interfaces connected to that particular router on all the interfaces. If we are using version 1, then this request packet will be broadcasted, and if we are using RIP version 2, then this packet will be multicasted, and uh, this request packet is sent among the neighboring routers and in order to get their routing tables and their updates. So whenever the requests from routers are received, the receiving routers will send their entire routing table in a response message. So as soon as the response message has been received to the uh, requesting router, it will update its routing table. And there are 2 type of updates usually occurs in a IRIP protocol. First one is your regular routing updates, and second one is the triggered updates. So the regular updates usually occur after every 30 seconds. So the regular updates after the 30-second timer, every router will send all or some part of its routing table to every neighbor in a response message. And the trigger updates are occurred whenever the metric for a route is being changed, and then the router will send its entire routing table. So let's see through an example now how does the routing will be done here in this case. So let's see, we have 8 routers now from A to H, and our source router is A. So we will start our packet will be sent via A to, and our destination is C. So we will choose the best route among the available paths. So first route, let's see, the first route is this one from A to B and then to C. This route has only 2 hops, and the second route is from A to D, then E, and then C. This route has 3 hops. So the third route has 4 hops, which is highlighted in green. So if RIP protocol is working here, so the best route which has the lesser count will be chosen to be the route number 1, which is from A to B and then to C. So the route 1 will be chosen. How this route will be chosen? It The routers will send all the requesting. If A want to request the packet among its connecting neighbors, then it will send the neighbors, and we have discussed this part, how this routing will be uh, done in our in our theoretical lecture. uh, it does computed this routing table based on the Bellman-Ford algorithm. So the routing table is been computed, and now the best route will be chosen as to be route number 1. So there are some problems which occur in RIP protocol because it works on a hop count, minimum hop count. So uh, suppose in this case the RIP will fail because the RIP doesn't chooses the route with the higher bandwidth. So bandwidth is a criteria which basically uh, tells about how fast your link is. So in this case, the if RIP is working here, so best route will be chosen to be the route number 1, which is highlighted in red. So assume now the route 1 has link bandwidth of around 500 kilobit per second, whereas route 2 has 30 megabit per second, and route 3 has 500 megabit per second. So but RIP will not choose the link with has a higher bandwidth because RIP works on a minimum hop count. So uh, if you are choosing the route 1 in RIP, uh, the route 1 will become congested very soon because of the packets coming into the networks are higher, and your route will become choked down after some time. In case you chose the route number 3, then then your packets can be transmitted very fast as compare if you are choosing route number 1. In this case, your packet will be very slow, but RIP works on the minimum hop count. It doesn't work on a bandwidth. And RIP takes very long time to stabilize because even for a small network it takes several minutes until the routing table has been settled after a change, because it will be sending the triggered updates, and all the routers will compute their routing table and then send the updates to the other neighbors as well. We have seen this in the Bellman-Ford algorithm. It also has the same problem, and RIP also has all the problems of a distance vector algorithm. For example, you have a count to infinity problem, and also the RIP uses split horizons to avoid an count to infinity problem, but it exists there. And there is another major problem in RIP, that RIP works on the maximum hops to be 15. If the hops are being increased to 16, then it doesn't work. It basically counts that 16th hop to be infinity. Also the link bandwidth utilization is very high because every router sends the updates after every 30 seconds. So your network will become congested if your number of routers are being increased. So that was all for today about the RIP working example. I hope you will see my other lectures as well. Allah Hafiz for now.